Hello, class. We are covering P6 factoring in this video. So I will be covering multiple methods of factoring here. And then we will do some problems so that you can assess your knowledge of the different methods of factoring. And if you feel like you need more help or more explanation, I include other videos from the previous math class that look at these different methods individually. So you can figure out which one you need more help with and just access those videos. Okay, so P6, factoring. Okay, so the different ones we're going to be looking at is common factoring, factoring trinomials, special factoring, like difference of cubes, difference of squares, and factoring by grouping, which is really comes from common factoring. Okay, so before we start looking at all of these different factoring methods, let's make sure you understand what it means to factor. Okay, so when you see directions that say, okay, factor this problem, what they're really asking you to do is to rewrite it as a product, as a multiplication problem. Okay. All right, so for example, maybe you have some, just the number 12. If they say factor this, you can rewrite that as a product, 3 times 4. Okay. If you have something like this, 6x minus 8, that's a subtraction problem, but you can rewrite this as a multiplication problem like this, so that if you multiply that out, that's a product. If you multiply this out, you would get the 6x minus 8. Or maybe you have something like this, x squared plus 3x plus 2. And you can rewrite this sum here, the sum of 3 terms, as a product, x plus 2, x plus 1. Okay, and we'll take a look at how I'm getting these answers here. So if you're like, how did she get that? Don't worry, we are getting there. Okay, and you can always check to see if you factored correctly by multiplying it out. Okay, so can always check if factored correctly by multiplying it out. And then checking to see if you get the original problem back. Okay, all right, so let's go ahead and start with common factoring. Okay, so with common factoring, what you're doing here is you're trying to find if there's anything in common that the terms have. Okay, so you're going to factor out the common factors. Okay, so for example, suppose that I have this 3x squared minus 6x. Okay, so here I can see that these two terms, starting with the numbers, I see that they have 3 in common. And then I also notice that they both have 1x in common. So the common factor here would be 3x. Okay, so if I factor out a 3x, then I need to figure out what goes in here so that I get this back. 3x times what would give me back 3x squared? Well, that would be x. Okay, 3x times x is 3x squared. And then same thing here, I would need to figure out 3x times what would give me 6x. So that would be 2, because 3x times 2 is 6x. Okay, let's take a look at another example. Suppose that I have this, 8x to the fourth, y squared, plus 6x cubed, y cubed, minus 2x, y to the fourth. Okay, so here, starting off with the numbers, I notice that 8, 6, and 2 all have 2 in common. So I can factor out the 2. And then I notice here that all of these terms have x in common. They all have 1x in common. Okay, so here, let me write down all the things that they have in common. All right, so far, 8, 6, and 2 have 2 in common. They all have x in common, at most only 1. And they all have y. This one has 4, this one has 3, this one has 2. So they all have at least 2. Okay, so that would be my common factor, 2xy squared. Okay, so then I need to figure out what goes inside here to get this back. 2 times 4 is 8, and x times x cubed will give me this x4, and y squared times 1, so I don't need anything there. And then the next term, 2 times 3 will give me 6. X times x squared will give me x cubed. And y squared times y will give me y cubed. And then over here, 2 times negative 1. I don't need to put a 1 here. Having negative and then the rest of it, it's understood there's a 1 in front. Okay, so 2 times negative 1 is negative 2. X times 1 is x. And then y squared times y squared is y4. Okay. Okay, so that's how I can factor that one using common factors. And let's take a look at this one. This last example kind of demonstrates how factoring by common factor relates to factoring by grouping. Okay, so what happens is when you're doing factoring by grouping, you eventually end up with something that looks like this. And then you can look at this as 2 different groups. This is one group. This is your second group. And we notice that this first group and the second group both have x minus 3 in common. So it's like, okay, well, I can factor out the x minus 3. And what happens is I'm left with 2x plus 4 here and minus 5 over here. Okay. And then I can just simplify the second one over here. 2x plus 4 minus 5 is going to give me 2x minus 1. Okay. All right, let's take a look at factoring trinomials. Hopefully you guys are all experts with this one, because this is one of the methods we use to solve quadratics. Okay, so factoring trinomials. Okay, so before we go into factoring trinomials, let's go ahead and have a look. And let's just recall how we multiply these binomials here. 2x plus 3 x plus 1. Okay, so if you recall how we multiply this, we use the distributive property. Starting with a 2x, we distribute it to all of the terms here. So 2x times x is 2x squared. And then 2x times the 1 is 2x. Okay, and then we do the same thing with the 3 here. I distribute it to all of these terms here. So 3 times x is 3x. And 3 times 1 is 3. Okay, so what I want to do here is focus on how we got these 4 terms. Okay, so this here, let's go ahead and simplify this. So it's 2x squared plus 5x plus 3, right? I combined the like terms here and I got the 5x. Okay, so let's just take a look and see how we got these 4 terms. So I got this one here, right? I got this one here by multiplying the first term times the first term. Okay, so this one over here, this term here, is the first term times the first term. And what I mean is this is the first term between here, these two. This is the first one, that's the second one. And between these two, this is the first one, that's the second one. Okay, so I got this term by doing first times the first. And then I got this one by doing the last one times the last one, right? Or the second term times the second term. Okay, and so when we do our factoring, we're going to be given a trinomial like this here, 3 terms. And what we're trying to do is figure out how to go backwards, how to figure out what we multiplied. And so here, when we're given the trinomial, we use this understanding that, okay, this 2x squared was created by multiplying the first term times the first term. So you have to figure out what times what will give me 2x squared, okay? And this is created by doing the second term times the second term. So you have to figure out what times what is 3. And then you look at all the different combinations and you try to find the one that will give you 5x for the middle term, okay? Okay, so over here, this 5x was the combination of 2x plus 3x. And we got this one from the outside product. And we got this one from the inner product. Okay, so we see here we got the 2x from the outside product, 2x 1 and 1. We got this here from the inner product, 3 times x. Okay, all right, so let's go ahead and take a look here. So now what we're trying to do here is factor a trinomial by going backwards. So like if you have 2x squared plus 5x plus 3, okay, then what happens is when we do this, we use the fact that we get this from first times first. So you have to figure out what times what will give you 2x squared. And that's going to be 2x times x. And then here you try to figure out what will give you positive 3. So that's going to be positive times positive or negative times negative, right? So if you have those two choices, positive times positive or negative times negative, you can look over here and it'll tell you which one to choose. So here, I know it'll be positive times positive. Okay, and then there's only one way to make 3 times 1, okay? But you have to make sure that you have it in the right place, okay? We can see from up above that it's going to be a 3 here and a 1 here. And let's suppose you thought it was 1 times 3. Okay, suppose you thought it was going to be this. Okay, so we see here 2x times x is x squared, 1 times 3 is 3, and oftentimes students think that, oh, all right, well, I got this one right because I get the 2x squared and I get the positive 3. but you always need to make sure that you also get that middle term. And we see here, to get the middle term, it's that outer product and that inner product combined. So let's go ahead and do that outer product, positive 6x, and that inner product, positive 1x. And when I combine them, I get positive 7x, and that does not match our middle term. So you need to make sure that you do have it in the correct order, not just making 2x squared and not just making 3 is enough. You also need to make sure that that outside product, inside product combined will give you the middle term. Okay, so if that doesn't work, you can always try switching them. And then when I try that outside product, I get positive 2x, and that inside product, I get positive 3x, and then combining them, I get positive 5x, and that's the one I want. Okay? All right, so why don't you go ahead and try these three? Let's go ahead and factor and try this one. X squared minus 2x minus 3. Watch your signs. 2x squared minus 5x minus 7, and x squared plus 4x minus 5. Okay, so go ahead and hit the pause button and give these three problems a try. If you want to come back and check your answer one at a time, that's fine. Or if you want to do all three and then come back and check your answers to all three at once, that's fine as well. Okay, so this first one, x times x to make x squared, and then I want negative 3. So I know one of these is positive and the other one is negative in order to get this negative 3. Okay, and so now I can check to see if it's going to be this one, positive 1, negative 3, or if it's going to be positive 3, negative 1. Okay, so if I choose this one, okay, so I definitely get the x squared and I definitely get the negative 3, but the question is, do I get negative 2? Negative 2x for the middle. So I'm going to check my outside product, negative 3x, my inside product, positive 1x. Combined, I get negative 2x, and that does check. Okay. And then over here, 2x times x to make 2x squared. I need one of these positive, the other one negative, and there's only one way to make 7. That is 7 times 1. I'll try the 7 there and the 1 here, and let's check. Outside product, negative 2x. Inside product, positive 7x, and that gives me positive 5x, but I want negative 5x. So this is not correct. However, it's so close. And these are, when you have this, just the wrong sign, that's a very easy fix. All you need to do, if you have the wrong sign, is just switch the signs. Okay, and then that will give me positive 2x, negative 7x, giving me negative 5x, which is what I want. Okay, so if you're off by the sign, not a big deal, just change them. Okay, and then over here, x times x to make x squared, negative 5, so I need one positive and one negative, and it looks like the 5 should go here and the 1 should go here, and then checking, that's negative 1x, and then inside positive 5x, and that gives me positive 4x, which is what I want. Okay, very good. All right, and then try this one, these two. See if you can get this one. See if you can get that one. And see if you can get this one. Okay, so go ahead and hit the pause button and come back and check your answers. Okay, so for number 4, it might be easier to replace the a plus b with like a variable. So like u, I'll use u. Okay, so if I replace the a plus b, then it'll look like this: u squared plus 5u minus 3. And having it look like this might be a little easier for you to wrap your mind around how to factor this, because now this looks like your regular trinomial, where this looks a little more complex, but it's not. Okay, that's just an illusion. Okay, a visual illusion. But you can do this if it makes you more comfortable. And then factoring this, it's 2u times u. And then one of these has to be positive, the other one has to be negative. I don't know which one. Okay. And then a 3 and a 1. I'll put 1 there and 3 here. When I check, I get negative 6u and positive 1u, giving me negative 5u. I don't want negative, I want positive. So that means I'm only off by the sign. So this one will be negative and this one will be positive. Okay, so, and that will give me my positive 5u. So this is your answer. But what you can do now is go back and replace the u with the a plus b. So it would be 2 times a plus b, and 2, no, there's no 2 there. And then a plus b plus 3. Okay? So you can see there, it's, like I said, it's just an illusion. This looking more complicated than it actually is. But feel free to use the substitution here so that visually it looks a little more familiar. Okay, and then over here, let's go ahead and, so this one here, I just want to mention here, so there are 2 choices to make 4t squared, right? You can do 4 times 1 or 2 times 2. Okay, and to kind of save you some time, if you notice that this is a perfect square, 2 times 2, and this is also a perfect square, 5 times 5, then it's probably going to be this, 2t minus 5, 2t minus 5. Okay, so that's something to look out for, and that's why I put this here as an example. So if you notice this is a perfect square and this is a perfect square, then instead of trying 4 times 1, try the 2 times 2 and the 5 times 5. Okay, now as far as signs go, so I kind of quickly did this here, minus minus. So remember, to make positive 25, you can do 5 times 5. That will give you positive 25, right? But negative 5 times negative 5 also gives you positive 25, right? So you have 2 choices there. It could be positive positive, or it could be negative negative. Okay, and the reason why I went with negative negative is here. Okay, because if they were both positive 5, then there's no way you're going to get a negative 20t for the middle term. Okay. All right, and then when you check this, so we see here that we do get 4t squared, and here we do get positive 25. And then if I check my middle term, there I get negative 10t. Here I get negative 10t, and that gives me negative 20t, which is what I want. Okay? Okay. Now, some special factoring. Special factoring, we have difference of squares and difference of cubes. But let's do difference of squares first. Okay, so if you notice that you have difference, meaning subtraction, of perfect squares, a squared, b squared, okay, then this is going to factor out to a plus b, a minus b, okay? And hopefully you already have this memorized from the previous class. If not, memorize it. Okay, so 4x squared minus 25y squared. So clearly both of these terms are perfect squares, and we do have subtraction. We do not have something for the sum of squares. We end up with imaginary numbers if we do. Okay, so here, so if you can first identify what's being squared. So over here, 2x is being squared, and over here, 5y is being squared. If you can identify what is being squared, then you can factor this. It's going to be 2x plus 5y and 2x minus 5y. But you have to first identify what are the two things that are being squared, okay? All right, now let's take a look at sum and difference of cubes. So like I said here, we only have difference of squares. When we have something like this, 4x squared plus 25y squared, when you have the sum, this is not factorable. Okay, it's not factorable under the real number system. It's factorable under the imaginary or complex number system. Okay, you end up with i's imaginary. Okay. All right, but for cubes, we do have sum and difference of cubes that are factorable. Okay, so if you have the difference of cubes or the sum of cubes, then both of these are factorable. So again, identify what is being cubed. And once you identify what's being cubed, that's what goes here and here. That's what goes here and here. And these are very similar. So what happens is you end up with a binomial. For both of these, you end up with a binomial here. And your other factor is going to be a trinomial. Okay, so very important that you understand that the second factor here is going to be a trinomial. Okay, and they're both very similar. Once you can establish these here, once you figure out what's being cubed, whatever's being cubed, A, that goes here. Whatever's being cubed, B, that goes here. Okay, and then once you establish what the binomial is over here, then you can derive the trinomial here based off of the binomial, because over here you're just going to square the a. Same here. And then over here, the next term is going to be positive there, but negative here. Okay. And then the middle term, you're just going to take their product, a times b. And then for the third term, both of them are positive. You're just going to square that second term. Okay. So these also need to be memorized. Okay, so let's go ahead and take a look at two examples. Okay, suppose that I have this here, 8x cubed minus 27. Both of these are perfect cubes. Okay, so we should be able to factor them. So let's identify what's being cubed. So over here, 2x is being cubed, and over here, 3 is being cubed. Okay, so once you identify what's being cubed, then you can figure out the binomial. And then once you know the binomial, you can go ahead and derive come up with your trinomial. So the trinomial says that for this first term, you're going to go ahead and square this one. So you're going to get 4x squared, and then it's positive, and then you just take their product. So that's going to be 6x, not negative 6x, but positive 6x. And then over here, this is just going to square the second term, so 9. Okay, so again, you just square this, 4x squared, take their product, 6x, and then square this, 9. Okay, so square it, take their product, and square this. And this trinomial is not factorable. Okay, so we can stop right there. Let's take a look and see what it would look like if we had plus 27 instead. So again, you would still go through the same process, identify what is being cubed, and this first, the binomial would be 2x, oops, that's a plus, 2x plus 3, and then over here, you get your trinomial. So we square this, 4x squared, and then this is subtraction. Remember, this one is the subtraction for the second term. Multiply them, so I get 6x, and then square the 3. Okay. Okay, so let's have you try a few. Go ahead and try this one here. X plus y squared minus z squared. Okay, and this one here, 125 minus x cubed and x to the 6 plus 8. Okay, so a little higher level than the other ones, but nonetheless, if you can identify the structure, the process is going to be the same. Okay, so go ahead and hit the pause button and come back to check your answers. Okay, so this one here is perfect squares. So it's going to be x plus y plus z, x plus y minus z. Okay, this one here is difference of cubes, and it's 5 that's being cubed and x that's being cubed. So it's going to be 5 minus x. Now, the reason why I put this one here for you to try out is because oftentimes students will write this in the reverse order just because they want to. Okay, so you're not allowed to do that, okay? Because 5 minus x is not the same as x minus 5, okay? So you need to make sure that if this here is 5 cubed and this here is x cubed, that the 5 goes first and the x goes second, okay? And then over here, now you can derive the trinomial. So it's square the 5, and then it's plus. Take their product, so it's 5x, and then square the x. Okay. And then this one here, again, if you can identify what is being cubed. Okay, so this one here is 2 cubed, and okay, okay. Are you okay? One of my neighbors just came by to drop off some goodies. Okay, let me get back to this video. All right, and so you're trying to figure out what's being cubed here. And so we have x squared is being cubed and 2 is being cubed. So it's going to be x squared plus 2. And now I can derive the trinomial here, square the first part, so x to the 4th. Take their product, but remember it's negative. Take their product, 2x squared, and then square the second term. Okay? So again, if you can identify what it is that's being squared or cubed. And this one over here, some of you guys might be like, well, how did you know it's not squares? How did you know it was cube? It was the other way around. Well, because I looked at this and this is not a perfect square, but it is a perfect cube. So I figured, oh, okay, if this is a perfect cube, then this is probably a cube. Okay. All right. So let's do factoring completely. So let's do this. So when it says factor completely, you have to check to see if you can factor some more. So for example, if you have 2x to the fourth minus 8x squared, I noticed that they have 2 in common and x squared. So I'm going to use common factoring first. So I'm going to factor out 2x squared, and that will leave me with x squared here and minus 4 here. And you might think you're done, but you're not, because even though you did common factoring, over here we have difference of squares. So I can factor this part some more. Okay. X plus 2, x minus 2. And then I just take a look at it. Nothing else can be factored. So now I am done. Okay. All right. So try number 2 and 3. X to the fifth y squared minus xy to the sixth. And try this one as well. This one, throwing in some fractions. That's right, fractions. That F word. Okay, give this one a try. I'm sure some will struggle, but give it a try. Okay, hit the pause button. Okay, so I like to start off with any sort of common factors because you either have common factors or you don't. It's not a right or wrong thing. Okay, so here they both have x in common and they both have y squared in common. So then that'll leave me with x4 minus y to the fourth, 4, 5, 6, yeah. Okay, and then we have perfect squares here. So this part can factor out. So that's going to be x squared plus y squared, x squared minus y squared. Okay, but I noticed that down here on the end, x squared minus y squared, this piece, we have difference of squares. So I'm going to go ahead and factor that some more. And that's going to give me x plus y, x minus y. And that would be my final answer. Okay? So you always want to look to see if you can factor some more. Okay, now with this one, so if you notice here, let's take a look at this example up here. We notice that they have y in common, and we always took the smallest exponent. So we factored out the smallest exponent. So here, there's y2, and here's y6, and so we factored out y2. Okay, so that idea of factoring out the smallest still applies here with fractions and negative numbers. So of these, so these are all x, so they all have x in common. The question is, what exponent do you use? So here, this is negative 1/2, okay, and that one is the smallest, so that's what you're going to factor out. Okay, they also have a 3 in common, so I'm going to factor out a 3 and x, and it's going to be negative 1/2. Okay, all right, so here, so 3 minus 1 is uh, over here. we need to make 3 halves. Okay, so the way you make 3 halves, okay, so they all have common denominators, so that's great. Okay, so you can focus on just the numerator. We have a -1, but we need to make 3. And remember, when we're multiplying like bases, we're going to be adding the exponents. So you have to think, okay, well, -1 plus what will give me 3? And that would be 4, right? So this would have to be 4 halves. Because when you multiply, you add the exponents. -1 half plus 4 halves. -1 plus 4 will give me 3. Okay? Same thing over here. So I need a -3 and I need an x. And I have -1. So -1 plus what will give me 1? And that would have to be 2 halves. And then here I have 3 times 2. And I will need, let's see. Actually, I don't need any x's because I need x to the -1 half. And that's already been factored out. Okay. Let's clean up our fractions inside the parentheses. 4 over 2 is the same as 2. 2 over 2 is the same as 1. And so I have this. And I have that trinomial, so I'm going to see if I can factor out this trinomial some more. So that's x and x minus minus 2 and 1, and that gives me -3x for the middle, so that is correct. And I can't factor anymore. Okay, so that's how you can factor completely. So factor, when they say factor completely, this means that you have to keep on factoring until you can no longer factor. Okay, if it only said factor, if you just did this first answer right here, that would be good enough, because to factor just means to rewrite it as a multiplication problem. To factor completely means to keep writing it as a multiplication problem until you no longer can. Okay, last part, factoring by grouping. Factoring by grouping. Okay, so this one, you can tell when you're going to be using this because usually there are 4 terms. Not always, but usually. Okay, and what you're going to do is you're going to break it into 2 groups. Sometimes there might be a situation where you need to rearrange the terms. If necessary. Okay. And then what you do is you factor common factors from each group. Factor common factors. Each group, one at a time. And then you're going to factor the common factor from the entire expression. So first you're going to look at each group, and then you're going to look at the entire thing. Okay. All right, so let's have a look here. I'll do one example, and then I'll have you try, and then we'll end it. Okay. So let's go ahead and factor completely. And suppose that I have this. Here, let's not do that. Okay. X cubed plus x squared plus 4x plus 4. Okay. All right. So right here, I'll use purple. this time. Okay, so this is going to be group 1, and then this is going to be group 2. Okay. All right, so starting with group 1, I'm going to factor out the common factor between x cubed and x squared. That would be x squared. Okay. Now I'm going to do common factor from this group. So there's a plus sign there, so I'm going to use the plus sign. And they have 4 in common. And I'm going to end up with x plus 1 here. Okay. So now what happens is, now that I'm done with each group, okay, now I'm going to look at the entire expression, and I notice that they both have x plus 1 in common. So that's what I'm going to factor out. So I'm going to factor out an x plus 1, and when I do that, I'm going to have x squared plus 4 left. And the x squared plus 4 sum of squares does not factor anymore. If I had x squared minus 4, then I would factor that some more. Okay. All right, so go ahead and try this one. Factor completely. So factor until you can no longer factor. And go ahead and do this one. X cubed minus 2x squared minus 9x plus 18. Okay, hit the pause button and come right back. Okay, so from this first group, they have x squared in common. So I will have x minus 2. Here, this is a negative. So very important that you use negative there. And I'm going to factor out a negative 9. And then here, negative 9 times x is negative 9x. And then negative 9 times negative 2 will give me the positive 18 that I want in here. Okay? And you should, if you do this correctly, what you have inside the parentheses here and here, they should match. Okay, if they don't match, check to see if you factored out this negative and that you change the sign here, because negative times negative will give you this positive. Okay, all right, so these two match. So I'm going to factor out the x minus 2, and I'm left with x squared minus 9. But that's difference of squares. So I'm going to factor out the x squared minus 9 like so, and that will complete my factoring. Okay, so that is it with the factoring. For your homework, figure out which ones you feel like you need extra practice on and focus on those. So 7 through 97 odd. Again, the chapter P homework is optional, and you can find it in the ebook on WebAssign. Okay, and the answers to the odd problems are right next to the problem. So you just click on the answer and it'll reveal it. Okay. If you feel like you need more explanations on each of these factoring methods, I will include some supplemental videos that I created for the previous math class. Okay, so you can look to see which factoring you need more help with. Okay, I will see you next time.